Hey, I'm Guac. I love you. Welcome to the third episode of Speedrunning Operating System Essentials, where I'm going to tell you as much as I can about a really complicated operating system concept in 5 minutes. So today we're going to be covering the CPU and its role in an operating system. So I'm not going to go over really low-level aspects of how the CPU works. I'm going to assume that you have a basic knowledge of CPU architecture, but I am going to tell you how that fits into an operating system. So we're going to start our timer for 5 minutes and get going. Alright, so what is the CPU? The CPU is the central processing unit. It is the main part of a computer. It accesses literally everything else and it does all the calculations. So we have access to memory, GPU, peripherals, everything else. Peripherals and displays and stuff. Okay, so with the CPU, how does the CPU work with an operating system? Well, the CPU has to do everything in an operating system, especially at the beginning. So we covered in the last time the booting process and how booting leads into the rest of the operating system running. But one of the things we didn't cover or briefly glanced over was how does the CPU know what it's actually connecting to? So the CPU gets something called the GDT from the bootloader, from the motherboard. So the motherboard tells the CPU, hey, here is the GDT, which is the global descriptor table, and it gives the CPU a bunch of information about what memory is installed in the system and how it can interact with it. So that gives the CPU access to all the memory. So it has a million lines that it can fill with data to get its stuff done. So the CPU uses the GDT to figure out what memory it has access to, and that's when it can begin initializing the boot process. But once let's say we've already gone through the boot process, we have all our stuff connected, we're in 64-bit long mode. Okay, so now, how do we actually process things? Well, we need to have something established called the IDT. GDT and IDT, very different things. The IDT is the interrupt descriptor table. A CPU interrupt is very, very important. A CPU interrupt is very simple. It's a signal that tells the CPU, stop what you're doing and process the thing that I need you to process. So there's 3 different kinds of interrupts. There's software interrupts, hardware interrupts, and CPU interrupts. You might think that hardware interrupt and CPU interrupt sound like the same thing, but they are not. A hardware interrupt is actually how most hardware devices communicate with the CPU. So they send a quick signal to the computer, to the CPU that says, hey, I need you to process something for me. Someone just pressed a button. I need you to process this now. So the CPU will delay that and process it. So a hardware interrupt goes through something called a PIC, the Programmable Interrupt Controller. Your keyboard, everything you connect to it has this. So a PIC is just a thing that it's like a pool for all the interrupts that are coming in from hardware. Because obviously you're typing a lot of keys a second. The CPU isn't going to be able to keep up with all that. It's not going to be able to manage those signals. It's going to get flooded. So the PIC serializes them, which means it gives them to the CPU one after another. So they go to the PIC first, and then they go to the CPU for processing. So the CPU can do stuff like render things on the screen, send more signals to the operating system, blah, 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 blah. Then we have software interrupts, which are, for example, in Linux, syscalls, which are, we ask the CPU to do something very, very specific. So we need it to shut down, that's a syscall, that's a software interrupt. We need it to access a certain file, which means going through the storage, or we need it to initialize some part of the memory, which means going through memory. So all of that is done with a software interrupt, which is sent to the CPU and says, hey, you need to do this specific thing for me that is related to the operating system and to the way you're connecting to the rest of the things. And then finally, we have CPU interrupts, which are pretty much the most important. So CPU interrupts are interrupts that are specifically on the CPU, pre-programmed, and they're definitive issues. For example, if you try to tell the CPU to divide by 0, you're screwed. That's going to render a CPU interrupt. The CPU is going to be like, hey, wait, I can't do that. So a CPU interrupt is when the CPU basically tells itself, hey, something's wrong here, we need to process this a different way. So when there's a CPU interrupt, the CPU checks the IDT, the interrupt descriptor table, which has a bunch of interrupt handlers set up which we set up in the boot loading, which are functions that the CPU can run when it runs into a certain interrupt. So there's a bunch of interrupts, like if you divide by 0, if you do certain illegal operations, like try to access memory that doesn't exist, that causes a CPU interrupt. So the CPU goes to the IDT and says, hey, what do I do if this happens? And in worst case scenario, it doesn't, like something goes wrong in handling that, and you get what's called a double fault, and you get screwed because you're like, okay, we really have to handle this. I'm going a little over time, it's fine. Okay, so it says, we really have to handle this, something's wrong. If that doesn't go through, you get a triple fault, and a triple fault always kills the system. So yeah, that is the CPU in operating systems. Thank you for watching.